Okay, let's say I have a rate, and it's my rowing rate, which is 3 miles in 1/2 hour. I can change that rowing rate to a unit rate by multiplying my numerator and denominator by 2, and I end up with 6 miles in 1 hour as my unit rate because there's a 1 in the denominator. Using that unit rate, I then can create equivalent rates. In 2 hours, I can row 12 miles. In 3 hours, I can row 18 miles. And in 4 hours, I can row 24 miles. I can then change this data, or these rates and unit rates, into a nice little table so it's a little easier to read. And we've seen these before. And I can record the miles per hour. So I have 6 miles in 1 hour, 12 miles in 2 hours, 18 miles in 3 hours, and 24 miles in 4 hours. I can then transfer that data into a graph because I have time, which is hours, and miles, which is distance, and I can graph each of those points on those pairs of points on a coordinate graph. So I have 1, 2, 3, 4 hours for time and distance. If I put them in increments of 5, I can go from 5 to 25. And then graph 1 hour and 6 miles, 2 hours and 12 miles, 3 hours and 18 miles, and 4 hours and 24 miles. And I can connect the dots and draw a line through them. So we were able to, from this one piece of information, this rate, we were able to create a table and a graph using the equivalent rates. When we take a piece of information like the rate, we create a rule or an equation, and from that we were able to create a table and then a graph. And this is one way that we can represent data, and they're called functions. And think back to 5th grade where you might have had a function box or an input-output box, and your teacher might have put a number into the box and something happened in the box and you got a number out of the box. And it was your job to figure out, okay, what's going on inside this box? So in this situation, the previous example, we put a 1 in the function box, and the 1 was 1 hour, and something happened in the box, and what came out was the number 6. So 1 hour went in, and we got 6 miles out. And what happened in the box was we multiplied by 6. So our function was to get y, we took x and we multiplied it by 6. This is my rule, or my equation. So a function is an input-output relationship that has exactly one output for each input. So think of your function box or your input-output box. X is the input and y is the output. And then if you think about your graph, on a graph, your x is your independent variable and your y is your dependent variable. So there we are able to graph ordered pairs, and an ordered pair is an x value and a y value. Input-output tables can either be vertical or horizontal. Most of the input-output tables we have seen have been horizontal, but tomorrow we are going to use input-output tables in vertical because we're actually going to create them and go and graph. Okay, so let's create an input-output table for the rule y is equal to x minus 1.5. So I have chosen the values for x because they are my independent variables. And if you think of your function box, you choose the numbers you want to put into the box. And in this case, I chose -2, -1, 0, 1, and 2. I could have chosen whatever I wanted to put into the box, but for this example, I'm trying to keep the numbers small. So I'm going to put -2 into the rule. So I have -2 minus 1.5, and -2 minus 1.5 is -3.5. And then where x is, I'll put in a -1. So I have -1 minus 1.5, which is -2.5. Now I'll put in a 0 for x. So I have 0 minus 1.5, which is -1.5. Then I put a 1 in for x. So I have 1 minus 1.5, which is -0.5. And finally, I put in a 2 for x. And 2 minus 1.5 would be +0.5. So if you can create a table from a function rule, you can do the reverse, and that is to write a function rule if you're given a table. So the first thing you need to do is compare each output to its corresponding input. And you ask yourself the question, can I add, subtract, multiply, or divide the input by any number to determine the output? And again, I think of my function box. What do I do to 1 to get it to 5? Well, if I'm just looking at going from 1 to 5, I could say, well, 1 plus 4 would equal 5, or 1 times 5 would equal 5. Either of these rules would work for this problem, the input of 1 and the output of 5. So I go to the next number in my input-output table, and I see I'm going from 2 to 10. Well, if I use the rule 2 plus 4 would be 6, and that's not what my output is. So I try the other rule. 2 times 5 is 10. So the rule 2 times 5 does work here. And then for the next, 3 times 5 is equal to 15, and 4 times 5 is equal to 20. So my rule is I multiply by 5. But to write it as an equation, to find a value for y, I take my x and I have to multiply it by 5. So my rule for this table is y is equal to 5x. Okay, let's try a couple other function rules. In the first table, I'm going to zero in on this 0 for x. 0 is nice when it's in a function table because it helps me figure out what's going on. And in this case, if I put 0 into my input-output box or my function box, I get out 2.5. For that to happen, that means I'm adding 2.5 to 0. Because if I was multiplying 0 times anything, the output would be 0. So I'm going to check and see if that adding 2.5 works for all the others in the table. And 1 plus 2.5 is 3.5, and 2 plus 2.5 is 4.5, and 3 plus 2.5 is 5.5, and 4 plus 2.5 is 6.5, and if I add it down this end, -2 plus 2.5 is 0.5, and -1 plus 2.5 is 1.5. So the rule is to find y, or the output, I take x and I add to it 2.5. So what's the output when x is 10? Well, y would equal to 10 plus 2.5, which would be 12.5. Let's look at the next table. How do I get from 2 to -10? How do I get from 4 to -20, 6 to -30, and 8 to -40? Well, if I multiply 2 times a -5, that would give me -10. And 4 times -5 would give me -20. And 6 times -5 gives me -30. And 8 times -5 gives me -40. So the rule is to find y, or my output, I take my x and I multiply it by negative 5. What's the output when x is 10? Well, y is equal to negative 5 times 10, which is equal to negative 50. Okay, let's look at an example in your guided practice. The rule is y is equal to 2.5x. So wherever I see x, I'm going to replace it with the numbers that I've chosen for my values for x, which are negative 2, negative 1, 0, 1, and 2. So the first one would be 2.5 times negative 2, which is negative 5. The second's 2.5 times negative 1, which is equal to negative 2.5. Next is 2.5 times 0. That one's easy. That's 0. Then we have 2.5 times 1. 2.5 times 1 is 2.5. And finally, 2.5 times 2 is equal to positive 5. Let's go to the top part of your guided practice to look at one that's a little bit more difficult. So for this one, the rule is y is equal to 2x plus 2. So I'm going to replace my x's with the values that are in the table, and I'm going to rewrite them with the new value in it and follow order of operations to figure out what my output or my y value is. So for the first one, negative 2, I rewrite the expression as 2 times negative 2 plus 2. And order of operations says do multiplication first. 2 times negative 2 is negative 4, and negative 4 plus 2 is negative 2. For the next one, I replace x with negative 1, so I have 2 times negative 1 plus 2. 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. And in the next one, I replace x with 0, so I have 2 times 0 plus 2. 2 times 0 is 0, plus 2 is 2. And then I replace x with 1, and 2 times 1 is 2, plus 2 is 4. And finally, 2 is replaced with 2, so 2 times 2 is 4, plus 2 is 6. And now I've completed that input-output table. So I hope this has helped you to understand how to create function tables when you're given a rule, and to find rules if you're given a function table.